Hello. Okay. 9.8. Halogenation of alkynes. In the previous chapter, we saw that alkenes will react with bromine and chlorine to produce the halide. In much the same way, alkynes are also observed to undergo halogenation. The, the one major difference is that alkynes have two pi bonds rather than one and can therefore add two equivalents of halogen to form tetrahalide. So first example, uh, alkyne react with one equivalent of halogens and we'll get uh, alkene. And if alkyne react with two equivalent of halogen, we'll get alkane. So look at the mechanism. First, the triple bond will attack one bromine and expel another bromine. So this is, and then the bromine uh, minus gonna attack the the compound as a nucleophilic attack, and then we get the product. And if we'll have two products, cis or Z, and trans or E. Cis is the minor product because it's less stable, and trans is the uh, major product because it's more stable. Because why is it is more stable than cis? Um, because the molecule uh, bromine is far away from each other, so it is more stable than cis because bromine is close to each other. 9.9 Ozonolysis of alkynes. So when treated with ozone or O3 followed by water, alkynes undergo oxidative cleavage to produce carboxylic acid. So look at this example of internal alkynes react with undergo ozonolysis and we'll get carboxylic acid to carboxylic acid. So look at the mechanism. So first, the alkynes, the internal alkynes react with ozone and we'll add three oxygen into the compound. We'll get anhydride compound. And after, in order to hydrolyze the anhydride compound, we use water. And first, we want to make the mechanism look easier. We'll separate the anhydride into two compounds, and separate we'll get this compound and this compound. After that, the OH will attack the second compound, and the first compound will attack the H, or like the same reaction as proton transfer, and we'll get two carboxylic compound uh, as the final products. And in the previous example, we use internal alkynes, but in here uh, we use terminal alkynes. When terminal alkynes undergoes oxidative cleavage, the terminal site is converted into carboxylic acid. So the terminal site is CH. So when terminal alkynes undergo ozonolysis, we get carboxylic acid and carbon dioxide. So first, we look at the mechanism. So terminal alkyne uh, undergo ozonolysis. We add three oxygen. We get this compound, and then in order to hydrolyze this compound, we use water, and at the end, the final product we get carboxylic acid, and carbon dioxide. 9.10 Alkylation of terminal alkynes. Alkylation is the transfer of an alkyl group from one molecule to another. In the previous section, we saw that terminal alkyne can be deprotonated if there is presence of a strong base. The result we leave with alkyl ion. So look at the example. We use the terminal alkynes, and NH2 acts as a strong base, and it will go grab a proton, and then the bond will left, and we get an alkyl ion. The bond will left go to into the carbon, and we'll get the alkyl ion. The reaction has powerful synthetic utility, so alkyl ion can function as nucleophile. When treated with alkyl halide or Rx, the final result we have internal alkene. So if the alkyl ion uh, react with the alkyl halide, we'll get the internal alkenes because uh, the the alkyl ion act as a nucleophile and go attack the uh, alkyl halide, and at the end of the product we get internal alkyne. Okay, look at the example. The terminal alkyne right here undergo the alkylation, which we use the strong base, which is NaNH2, and the alcohol halide that we use is ethyl iodine. So first, look at the mechanism. Uh, First, the strong base gonna go to attack the hydrogen from the terminal alkyne, and we'll get the we'll get the uh, alkyl ion, and the alkyl ion will in this case alkyl ion acts as a nucleophile and gonna go to attack the ethyl. We grab the ethyl from the uh, ethyl iodine and expel the iodine ion, and the final product we get this product right here, which the ethyl will connect with the carbon, and this is the alkylation process, which go from the terminal ion into internal ion. So the transformation proceeds via an SN2 pathway and provides a method to install an echo group on a terminal alkene. This process is called alkylation. The process is only efficient with metal or primary alkyl halide. If secondary or tertiary alkyl halides are used, the alkyl function primarily as a base, and elimination products are obtained. So, example 2, we use the acetylene. So we can turn acetylene into the internal alkene by adding the by add, by undergo the alkylation process twice. And first process we get the internal alkene, and the second process we get the uh, internal alkyne. So look at the mechanism first. So like before, the strong base gonna attack the proton, and we get uh, the this ion right here, Alkyne ion right here, and this ion gonna attack the echo group from the echo halide, and we'll get the terminal alkene. This is the first step, and the second step, the strong base gonna attack the proton or hydrogen from the second uh, in the second time, and we get the Alkyne ion, and then the Alkyne ion gonna act as a nucleophile, gonna attack the echo from the echo halide right here, and which is in this case is air prime, and at the end we get the final product, which is uh, internal alkyne. So that's is the end of my presentation. So thank you. Bye.